What's up, everybody? Wrong camera. What's up, everybody? Welcome to your science. So, new unit. Let's look at the unit as one whole thing. Here's what we're doing, and it's a short unit. I'd like to bang through this in like maybe 2 weeks, maybe even less, and do a quick test on it. And really, it's on one state standard. This is the stuff I want to do this unit. I'm going to add one tiny little bit about soils being made, but we'll get there. Don't worry about that. What it is, it's going to take the water cycle. Again, you've already had some exposure to this. We'll do it a tiny bit more. Nothing new, just review it. Make sure we know what we're talking about with the water cycle. I'm pretty confident you already do. Um, then we're going to talk about what would affect how much water when we really focus in on this section down here. How much water goes in versus how much water goes across the surface. That's the meat and potatoes. This is the big one. This is the hard one, honestly. Um, And then three, these crazy vocab words: porosity, permeability, and water retention. We'll have a lab on that, a double lab. In fact, here's what I should have done: IJK. This is what you're going to be working on. My face disappeared. New software. We're a little bit off here. I is going to be step one from the all MP3 assignments. J, that one will be a little bit more to it. We're going to bang out today. No big deal. J's going to have a little bit more to it, and K is a little bit of a heavy lab. It's also one that I think my only way through this is if we have kind of half the class working on one thing and half the class working on the lab, in terms of how much help people need with it and in terms of how much stuff we have. I've got limited supplies on figuring those out. So bear with me. We'll have different people working on different things as we go, but we'll all get there. You'll do great. All right, so water cycle. Have you ever had your yard or somewhere locally? In fact, it's very likely like that right now. When I go home, um, where we see that there's water pooling up on the surface in yards, running across farm fields, things like that. The crux of this unit is going to be what would affect those. And here's all your answers. I mean, not the answers, but here's the topics. The amount of precipitation that seeps into the ground or runs off is influenced by a lot of stuff. And so this is where it gets a little bit heavy. What is your climate? What's the slope? What is soil, rock type, vegetation, land use, and degree of saturation? And then how do those things that we'll uncover in the lab also affect it? So that's where we're going. And here's what Regents questions tend to look like. I'm going to have you do something with those towards the end of this little lesson. But let's start, again, keeping life simple, just with the water cycle. And I'm not even going to do as much. When I did this the first time, yes, you've seen these exact notes. And when I did it the first time, I had you drawing out the drainage basin. We're not going to do that. We'll keep it simpler. Um, the idea here is here's kind of a cutout view of a body of water with water going up into the sky, forming clouds, raining back down, and running back into that body of water. Very basic definition of the water cycle. So let's chuck the easy ones in there. When water goes from its liquid states to its gas states, evaporation. It evaporates, right? So that's where we're going to say this begins. Even if it's a cycle, it doesn't begin, but that's where we'll start. Next, I brought this up once. I said that there's a special form of evaporation when it comes right out of trees. I'm going to draw a little tree right here for this arrow to say that water, if it enters the atmosphere as a gas from a liquid, but through the leaf of a tree, which to me is really the same thing as evaporation, but there's a special word for it when it comes through a tree, which is called transpiration. Put it there so it's easier to see. So out the leaves of a tree is transpiration. Off of the surface of a water or a puddle, whatever, is evaporation. You can slap those together and make a combo word called evapotranspiration, which would be all the water that goes from liquid to a gas. We'll keep them distinct for now. Eventually, this water vapor forms back into a liquid, which we call condensation. And we beat to death in Wrecking Period 2. No reason to go down that rabbit hole again. Eventually, the droplets of water, yes, clouds are water, and eventually the droplets of water in those clouds are going to be heavy enough that we get precipitation. Red, easy to read here. How about blue? Not much better. I guess just being with that in the background. Precipitation. All right, then it hits the ground, and yeah, we did drainage basins, we did the nature rivers. That's all still well and good, but really where it gets interesting for this unit is what is the balance between how much goes into runoff and how much goes into infiltration. So I'd like to blow up this little corner down here if we could. And yes, again, we did do some of this. I agree, but we got to bring it back up for this because I'll stick with red. That's easiest. So if it enters streams and rivers or just looks like these photos down here where it's pooled up or running across a field, we call it runoff. Water that remains on the surface. If it's water that works its way down into the surface, we call it infiltration. And this unit is all about what conditions might lead to more runoff versus what conditions might lead to more infiltration. One of them, the easiest, I think, the one that's most intuitive, people usually guess correctly. What's your guess? Hill slope. What if it's a steep slope? Water lands on a steep slope. Would you guess that that leads to more runoff or more infiltration? It's going to be like solving all those problems for all of those different variables. Okay. Hint, hint. Steep hills have more runoff. As you work your way down, you might get to this line. We talked about what you do at the beach, which a lot of us said, yes, that's exactly what we did. And some of us said, no, we've never done that before. If so, you're depriving yourself. Go to the beach, dig a hole, and eventually that hole will hit water. And when that happens, that line itself is called the water table. Two zones. Again, let's review. We're going to keep on going smaller here. Sorry. The top one, where water is infiltrating down and there might be air in between the particles, is called the zone of aeration. Aeration. Whereas as it goes down and it gets eventually to where there's only water in between the particles, up here there's going to be air and the trickling water. Down here it's completely filled. There's going to be the zone of saturation, separated by the line called the water table. So now, yes, we did that last unit, but now we're going to have to maybe unpack it a bit more. What if we get a lot of infiltration, a heavy rain, or a big snowmelt like is happening this week? Well, water's going to be seeping into the ground more, and yeah, there will be a lot more runoff collecting, but there's going to be a lot seeping into the ground as well, which means that the water table is going to be coming up, 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 up. In fact, some of us have yards. This could be that the water table is just so high that it's in the yard or in your basement. If you've got an old house like me, the water table gets this high, I get kind of a muddy basement no matter what, no matter how much you pump it out. Yeah, that'll be the deal. Figuring all that out. That's where we're going. Figuring out what happens with wells. This is kind of represents a well. You jam a big pipe into the ground, you suck water out. That creates this cone of depression in the water table. But what kind of usage issues are there with that? With maybe pulling out too much at once, or with seasonal fluctuations and all of this stuff, all of this balance between runoff and infiltration. Okay. Very broadly, there's a water cycle. That's not the answers to the whole entire unit. We got a lot of work left to do, but consider, if you would, what kind of conditions might lead to this. Start to think about this thing I'm going to ask you right here. Ask you to do for the classwork. It's really going to rely on you reading this second part of this, the thing that we're going to do in J. Yes, we're foreshadowing. We're guessing what some questions might be. Here's all the things that might be in there. So either with that or water cycle things, here's your job. You're going to have a classwork quiz, which is going to be some very basic vocab on the water cycle, which I don't anticipate being too difficult. We'll see. The second part of that is going to be to look at these 4 diagrams, which I stole from 4 different regents, all ones that mention the water cycle at some point. So these are exact regents diagrams. Just I took out the questions. So that's what you're going to do. You're going to invent a question for one of these. You're going to say, I picked diagram A, that's that one, or B, or C, or D. You can use the letters, you can use the concepts, you can use whatever. Come up with what you think is a good Regents question about what might be going on at one of these things. Okay? And if you're like, well, that's hard, I know. But that's the challenge. But come back up to the standard. Again, here's all the stuff that we're going to learn this unit. And yeah, we might not know what porosity, permeability, and water retention are yet, so I don't pick that one. But pick some of this other stuff. What about the water cycle? What about seeping into the ground? What about this? Could all be possibly a question that was asked on one of these things. I bet you can do it if you take a minute and think about it. It's not an easy instant answer. It's just sit there and think for a minute or two, see what you can come up with. That'll be part of the Google form along with the other questions. Good luck. You'll do it, and we'll then get going on. Some of you going on J, some of you going on K, and getting this unit underway. That wasn't meant to rhyme. Sorry. That's all in for now. Thank you.